information. If f external net वेक्टर हम सभी का 0 है, it means a comma is 0, the mass of the system is not 0 and mass is constant of the system. It means d over dt of v comma is 0. It means that is velocity of center mass is constant. Clear? If the external force, net external force is 0, then VCM is constant. Very important result. If initially VCM is at rest, it will remain at rest even the particles making the system are moving in different positions, but VCM will remain at rest if initially it is at rest. In this condition, by chance one component of the external force is 0, others are not 0, the component in whichever direction of the external force is 0, center mass will remain constant in that direction. For example, if Fx external is 0, then velocity of the comb in x direction will be constant. If it is 0 initially, it will remain at rest. Y component can change, Z can change. If initially x component is 0, it will remain 0. Similarly, in y direction and z directions. Okay. Now, when f external is 0, then v comma is constant. It means this part is constant. It means total mass of the body of the system is constant, upper part will be constant. It means these are momentums of the particles. The vector sum of the linear movement of the system will remain constant. Under this condition, if f external is 0, then m1 v1 vector plus m2 v2 vector plus and so on plus mn vn vector is constant. It is law of conservation of linear momentum. Clear? Okay. Hello dear friends. Today we will discuss about motion of the center mass, connection with the forces, what the effect of the forces on the motion of the center mass. Clear? These are two diagrams as you have seen. It is a ring, a smooth rod, length AB, AB is the string, in extensive end, its length BL, it is capital M mass. From this position, this system is released, then capital M mass will come down by the gravity, the ring will move along the rod, smooth rod. But in this case, how the center mass is moving, we will discuss about it. Same the problem is here. It is a smooth sphere, it is a hollow smooth sphere. Inside it there is a very small sphere of radius r, radius the bigger is 6r. When this sphere is released from that position, it comes down and reaches to that position this side. In this case, center mass, how the behaving, we will discuss about it. The concept which will be used here, I would like to discuss separately. For example, x is m1 x1 plus m2 x2 divided by m1 plus m2. टू बॉडी सिस्टम सपोज कर लिया एंड f external along x-axis is 0. Suppose initially velocity in x direction of the center of mass of the system is 0, then center mass will not change horizontal in x direction. It means delta x com will be 0. Individual bodies can change their positions. m1 delta x1 plus m2 delta x2 divided by m1 plus m2. So m1 delta x1 equal to minus m2 delta x2. So individual bodies will change their position according to this law. In two body systems, let us see this result in these two situations. Clear? If you think about forces on this body, capital M force is acting vertically downward. On the bead smooth Sara system, its weight will act, reaction will come from the rod. External force is due to gravity, vertically downward, by the rod vertically up. So external force is vertically upward and down direction, and thread will exert tension, thread and ring, and this body is the system, constituting system. So tension will be considered as internal force. So in this situation I can say in horizontal direction, or if I take x and y axis, this system in xy plane, in x direction there is no force. So initially the system is at rest. I have hold that body here. Initially the system is at rest. It means velocity in x direction will be 0. It means center mass will not change in horizontal direction, in x direction here. For example, let center mass of these two systems is between them. Suppose कर लीजिए इस पोजीशन पर है, at that position, it will remain at that position, but it has come down. Its position at in this figure is here, and that figure is come down. It is coming down because vertical forces are acting there, so it will change. But horizontally in x direction there is no force, so it is not changing in horizontal direction, it is coming down vertically. Now the question is how these individual bodies will change their positions. Let us find displacement of the ring. Displacement of the ring is d when the string makes theta angle with rod. d1 मान लीजिए displacement of the ring. In horizontal direction, displacement of capital mass d2. If I apply that condition here, m1 small m into delta x1, change in the x coordinate of the body, center mass of the body. In this case, delta x1 is d1, that is equal to m2 capital M into change in position of center mass second body is d2, it is coming closer, it is shifting left side, so delta x2 is minus d2. So clearly m d1 equal to capital M into d2, but d1 plus d2 is equal to L minus, clearly d1 plus d2 equal to L minus L cos theta. So you can calculate d1 and d2 easily from these two equations. It is 1 minus cos theta. Clearly d1 will be equal to capital M divided by small m plus capital M into L into 1 minus cos theta, and d2 will be equal to small m divided by small m plus capital M into L 1 minus cos theta. So in this case, how small m and capital M are changing their positions when center of mass is not shifting in horizontal direction. Second case, it is a smooth sphere placed on the horizontal surface. This is also smooth. Inside it, a small sphere of radius r is placed. Its mass is capital M. It is released from this position. So let us think about the forces. Weight acting vertically downward on this body. Similarly, 4 mg, 4 m is the mass of the bigger sphere. Vertically downward, normal reaction vertically upward. Clearly in this case, in horizontal direction, in x direction, there is no force. So when there is no force in x direction, velocity of the center of mass in x direction is 0. It means center of mass will not change in x direction. The same concept I am going to apply in this situation also. When this sphere comes to that side, it will rise up to the same height because of conservation of mechanical energy. Clear? Okay. When this sphere comes to that position, then bigger sphere shifts in x direction. I want to find out capital sphere is shifting how much distance in x direction. Okay. Center mass of bigger sphere and small sphere is somewhere between center of the bigger sphere and center of the small sphere. Nearer to the bigger mass, it will remain in that position horizontally. Vertically it will come down, then will go up to the same level. So center of mass of the small sphere is 6r, 5r away from the bigger sphere. So it will move on the radius of 5r. When it comes to that position, it is shifting in x direction by 10r. Clearly, it is 5r, 10r. Capital M mass sphere is shifting in negative x direction by 10r, but sphere also moves that side. It means small sphere is shifting towards left by 10r minus d. So very important information. If we keep the capital bigger sphere constant, small sphere is shifting 10r distance this side, because center of mass does not change its position. It is common center of mass, it is not changing its position. So bigger sphere has to shift this side by d distance. So capital M mass sphere will shift towards left by that much distance. Clear? So if we apply this equation here, small m means capital M, mass of that one, because it is shifting left side, so negative sign, this equal to minus m2, bigger sphere, its mass is 4m, it is shifting right side, x coordinate is increasing in this side, this time it is d. If you simplify it, you will find 5m into d equal to 10 into m into r, or you can say d equal to 2r. So capital sphere will shift towards right by 2r distance. Clear? Let us take one example of conservation of linear momentum and center of mass related. It is a bigger block, capital M block, and there is a track, horizontal track of radius capital R. All the surfaces are smooth. This surface is also smooth. Capital M block can move right side or left side. There is a small m mass body. All the surfaces are smooth. This is released from that position, so it will come down and move like this. So we are going to discuss about motion of capital M and small m. Clear? In this case, if I take system capital M block with track and small m body, mg is acting vertically downward, that is external force. Again, in horizontal direction, there is no external force, so center mass will not shift in horizontal direction again, and linear momentum will also be conserved in horizontal direction, because there is no external force in horizontal direction. Or I take x axis and y axis, so in x direction there is no force. Let us calculate speed of small m body when it reaches at the lowest position, and by that instant, what is speed of that bigger block? Suppose it is v0, and how much distance capital M block shift this side when small m reaches at the bottom. Okay, again center mass will be somewhere between lowest position and that one. So center mass will remain on this line. It may move up and down only in horizontal direction, it will not shift. Clear? Small m body moving on the radius capital R minus small r. Suppose capital M block body shifts this side by d, then small m body will shift in this side by r minus d, because when it reaches there, it shifts r minus r if it is at rest, r minus r horizontally, but it goes that side, it will take it back also. So small m block shift right side towards positive x direction by r minus d distance. So if I apply m1 delta x1 equal to minus m2 delta x2 here also, so we can find who will shift how much distance. Let us calculate shift by capital M mass. So m1, suppose करिए m1 is that one small m body, m into r minus d, this is equal to minus, that will be minus because it is plus because small m shifting towards right. Capital M block shifting toward negative x direction, so its shift will be minus d because its x coordinate is decreasing. If you simplify it, you will find small d equal to small m r minus r divided by small m plus capital M. So it is the distance by which capital M block will shift that side. Let us calculate velocity of the smaller m block when it reaches at the lowest position. Here we have to apply conservation of linear momentum in x direction. So initially momentum of the system is 0. Finally, final momentum of the small m block, small m body, small m into v I cap minus capital M into V naught I cap. So Pi equal to P final, you will get small m into V equal to capital M into V naught. Now it is the relation between horizontal speed of the small m and capital M. Now conservation of mechanical energy, because all the surfaces are smooth here. Let us apply conservation of mechanical energy. Loss of gravitational potential of the small m mass, that is mg into r minus r. Gain in kinetic energy of the small m mass, half small m v square plus gain in kinetic energy of the capital M block, half capital M into v naught square. If we put value of capital V here to find V naught, that will be equal to half small m capital M V naught divided by small m whole square plus half capital M V naught square. If you simplify it, you will get V naught square equal to m root of 2 into g r minus r divided by capital M bracket small m plus capital M. It is speed of the capital M block. Clear? Okay. Let us take one example for conservation of linear momentum and center of mass. A body is projected from this point, mass of the body is 5 kg, speed is 20 meter per second. At the highest point there is explosion. In that explosion energy is released. So whatever kinetic energy is there, in explosion energy becomes double of that kinetic, and this breaks into two parts, 4 kg and 1 kg. At the highest level they will move with different speeds, fall on the same horizontal level. Problem is to find distance between them. Clearly only mg force is acting vertically downward, so center mass will not deviate, it will move as it is. So center mass will move on the parabolic path as it was moving initially, but these fragments will move here and there. Clear? So let us calculate separation between them. Now at the highest point speed will be 20 cos 60. 20 cos 60 is 10 meter per second. So at highest point, because internal forces, explosion is taking place, conservation of linear momentum can be applied. Children think about external forces acting here, mg, so we cannot apply the conservation of linear momentum. No, it is wrong. When there is explosion is there, so internal impulse is acting there, so at that point there is no external impulse. Mg cannot change momentum at a point, only impulse can change. So impulse of the mg is 0 at highest point. So impulse of the internal force is there, so momentum will be conserved. In this case, because it is moving horizontally, so in horizontal direction, momentum will be 5 into 10 equal to 1 into v1 plus 4 into v2, or 50 equal to v1 plus 4 into v2. Now conservation of energy at that point becomes double of the kinetic. So half m into v square, 10 square, due to internal forces, explosion, total energy kinetic becomes this one after the explosion. This will be equal to half into 1 into v1 square plus half into 4 into v2 square. On simplifying these two equations, half is cancelled. It is 1000 equal to v1 square plus 4 v2 square. From 1 and 2, you will find after solving v1 is 30, v2 is 5, or v1 is minus 10, v2 is 15, means both are moving same direction, 30 and 5. 5 the speed of the 4 kg block, 30 is the speed of 1 kg spot at that point. If they move in opposite direction, then 1 kg block go back by 10, v2 moves forward by 15, but center mass will continue to move on the same one. Clear? Now let us find separation between them. Now you can find relative velocity, separation in horizontal direction along x direction. This equal to v relative 25, v relative again 25 into time taken will be same, half of the time of flight. So that is ten sin 60 in this case, that is equal to 25 by 2 into root 3 meter. Clear?